In this problem, they want you to get the density of air as a function of altitude y, given the pressure function, which I will write down below. So the pressure function P is going to equal to P naught, which I'm going to say is the pressure at sea level, times 1 minus LH over T naught to the power of Gm over RL. And LH and T naught, they're all, temperature, lapse rate, height, sea level temperature, and M is the molar mass of atmosphere, R is the ideal gas constant. So these are all just a bunch of constants. The only thing that are not constant are the pressure, I guess, yeah, so pressure P and H. Those are all H being the height. Those are things that can change. So given that, what is the density of air? So what we're going to do is we're going to continue to use this relationship of pressure as a function of height. And that's going to be negative rho times G. So as you can see, the pressure being a function of height means I have to take the derivative of this and find rho in the process of that. Now, H is actually just a fancy way of saying Y, okay? So what we're going to do is we're going to go ahead and just do a substitution um, for that, just so it fits our actual problem or our equation right here. So d over dy of P naught 1 minus LH over T naught to the power of Gm over RL is equal to negative rho G. To take a derivative is, not terribly hard, but we'll take it one step at a time. So, oops, I'm sorry. I guess I have to put a y in there. So a derivative of something, if it's multiplied by a constant, you take the constant out. So that's the first step. So we'll go one step at a time. This is P naught d over dy of 1 minus Ly over T naught to the power of G m over RL. And that's going to equal to negative rho times G. Secondly is since the function of y is nestled in a parentheses with an exponent attached to it, the derivative of this would then come about from taking the exponent, bringing it down in front, bringing this the argument of inside the parentheses here, and then subtracting the exponent of it by 1. And that's it. Oh, I'm sorry, not that's it. And then you multiply by the derivative of what's inside the argument, the parentheses. So the derivative of what's inside the parentheses is going to be 0 because the derivative of 1 is 0 minus, and the derivative of L over T naught times the y variable is just going to be the constant L over T naught. And that's going to equal to negative rho G. Okay. So simplifying this just a little bit more, we're going to go ahead and get P naught negative LGM over RL T naught 1 minus Ly over T naught to the power of GM over RL minus 1 equal to negative rho G. Good thing little treasures come about every now and then. The L's cancel out. So now we're left with, and what I can do is I can actually just take out the negatives. Since they're both negative on both sides, I'll go ahead and just take it and divide both sides by -1. This makes them positive. And I'm going to go ahead and isolate rho by taking the whole thing and dividing it by G. So now what we have is P naught L, I'm sorry, is a P naught M over R T naught 1 minus Ly over T naught Gm over RL minus 1. And the G, of course, also canceled out. That's why I just had P naught M and then RT naught at the end. So this is the function right here for the density rho. And as you can see, these are all constants except the y, which is the variable. Well,